All right, welcome to the first video of section 3.4. So you've been learning some different ways to solve quadratics, to polynomial equations. You've learned factoring, completing the square, graphing, taking the square roots, and each method is used in certain situations when your equation has certain characteristics that make that method the most convenient. But sometimes you're going to find quadratics that, for a variety of reasons, either aren't able to be factored, they're not perfect squares, completing the square becomes too messy and complex. So there's an alternative method that you can use, which is called the quadratic formula. Now, this is something you were all introduced to in Algebra 1, and what it is it's a formula using the coefficients of each term, so your a, b, and c values that you get from standard form, and all you do is you take those values and plug them into your formula, and it will produce the solutions to your equation, so the zeros, the roots, or the x-intercepts. So before we show an example of that, let's look at the quadratic formula. So you should all write this out in your notes. You're going to want to have this written down. And so the quadratic formula works when you have a quadratic equation that's in standard form, so ax squared plus bx plus c equals 0. This is key right here. If your equation is not in standard form, then these values will not give you the right solution. So you always have to make sure you get your equation in standard form first, which is equal to 0, and using the values for a, b, and c from your equation, you plug them into this formula here, which is x equals, and it's a big fraction, negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, you were introduced to this in Algebra 1. There's different methods for memorizing this. Some of you may have heard the song, the formula sung to the tune of Pop Goes the Weasel. I know that was a really common way that some teachers in other classes introduced this as a way to memorize the function. But this is something that you will need to memorize to be able to use. You're not going to be given this on notes or on the test. So again, make sure you write this down in your notes. And all you do is you take whatever your numbers are for a, b, and c, and you just plug them in here. Okay? You need to be careful with your signs. You've got a negative b plus or minus the square root of b squared minus 4ac all over 2a. So the key mistakes that people made, or common mistakes, are forgetting the negative sign or not multiplying correctly with the negative, the order of operations, not doing things in the correct order. So it's just basic arithmetic. You just have to make sure that you go one step at a time in order to solve it. So let's go ahead and look at an example, and you'll get to see how we actually use the quadratic equation. So here's an equation that we want to solve using the quadratic formula. Now, the first thing you're going to notice, we've got x squared plus 3x equals 5. Is this in standard form right now? And if you look at it, the answer is no. It's not equal to 0, so it's not, all of the terms are not on the same side. And we need to do that first before we can get our values to plug in. So let's go ahead, and first thing we want to do, we've got our original equation. Let's put it in standard form. So we subtract 5 from both sides to get into standard form. So now we've got x squared plus 3x minus 5 equals 0. All of our terms are in descending order from highest exponent to lowest exponent. So we've got our variable squared, then our variable to the first power, and then our constant. Okay, that's standard form right there. Now what we want to do is go ahead and pull our a, b, and c values from this. So you'll see right here, there's no number in front of x squared, but when you have that, that means that your a value is just equal to 1. this is 1x squared. Our b value is equal to 3, and our c value is negative 5. So now we have our quadratic formula right here. And the first step you always want to, again, rewrite your quadratic formula, but replace all of the letters with their values. Now you want to make sure that you use parentheses to put your numbers in, especially here for A and C, so you can keep track of these negative signs. And all you do from this point is you go ahead and solve. So again, we plugged in 1 for A, 2 for B, or 3 for B, and negative 5 for C. And what we're going to do is just go ahead and simplify this in the correct order. So let's go ahead first. We want to simplify what's under the radical. So we've got 4 times 1 times negative 5, so that's negative 20. So 3 squared minus negative 20 is going to give us 29. So we have negative 3 plus or minus the square root of 29, and then 2 times 1 is 2. Okay, so we simplify this, and this is our radical that we have right now. And we can go ahead and there's nothing else that we can simplify in here. 29 is a prime number, so there's no factors that we can take out. So we would leave this as negative 3 plus or minus root 29 over 2. And to get our two answers, we have negative 3 plus root 29 over 2 and negative 3 minus root 29 over 2. Now, it's really common for your answers to look like this. You know, they may have the radical in there, they may have fractions, they may have negatives. That's all completely fine. Don't be caught off guard if you don't come out with nice whole numbers. A lot of times when these equations aren't factorable, or when you're using the quadratic formula, it might be because it's a difficult equation that has some irrational answers like this. Okay, so again, we get our A, B, and C values, which are 1, 3, and negative 5, and we simply insert those. So 1 for A, 3 for B, and negative 5 for C. And you always want to simplify what's under the radical first. Okay, so you do your 4 times AC, subtract that from B squared, then you have your radical. Now, in another case, if this was a perfect square, you would want to simplify this and further reduce this fraction. So where you stop depends on what values you have in here, and if they are whole numbers or fractions or something, you always want to simplify it as much as you can. All right, so to practice, what I want you guys to do is you've got these 3 equations right here, and I want you to solve each of them using the quadratic formula. And there's also some couple questions that are going to pop up that I want you to answer as well before you get started working on those. So go ahead and answer the questions as they come up, and then in the final text box, type your answers for each of these 3 problems.